Hi, I'm Joe Campbell, and I'm going to show you some of the projects I'm working on. The first of them being this anatomical steel heart. It started out with a small model that I took a transfer from, and then wound up projecting that into a large sheet of steel, traced that out, cut the patterns, hand formed everything, and then torch welded it. And unlike the other process where it's MIG, metal inert gas, torch welding is using oxyacetylene, and the reason for that is that it leaves your steel very pliable, where you can actually go back in and work it. So in an application like this where it's very organic and you want to have these multiple curves, and you're going to go back in and work over the steel multiple times, you don't want the MIG process, which is going to leave a very, very hard weld, and it won't allow you to work the metal the same way. And it's all hand formed. There are no power tools used in this at all. The one ventricle will be a water chamber, the other ventricle will be a fire chamber, and the same principles that work in the heart, where it winds up pumping blood through your system. Instead, this is going to be pumping the water through itself and heating it instead of oxygenating it. Once these are finished, it will run up through the atriums and out the pulmonary artery and back into itself over on the other side, and then eventually come out of the aorta as steam. The whole principle behind this is it's a thermal mass sculpture. There's going to be burner jets inside of it, very similar to this. There'll be two of them. And what they're going to do is come up through that one ventricle, and then I have some old heater cores that what these do is they hold, they're going to act as a heat exchanger. And this gets filled with water, and then it placed on top of the flame, and the heat energy that gets transferred into this gets transferred into the water, turning it into steam through the honeycomb structure. And the reason this works is there's enough surface area. The honeycomb creates a large surface area that allows the heat to easily transfer into the water. Through here are tubes running in one direction and air vents running in the other direction. That cross pattern honeycomb is what really allows it to transfer the heat. Band contacted Frank's Kitchens and was looking for staging. This is the backdrop that they wanted for behind their set. And then there's going to be projections behind it and screens that the projections go through. My main task on this was to weld the aluminum structures together to create this modular system. Created jigs to have all the angles the same, everything set at 4 degrees, and then stops so that the pieces that would slide into these aluminum extrusions to hold the structure together would be at the same length, so that when it all flat packs down, when you take this whole structure and break it down and you're ready to ship it, that everything's the same size, all the angles are the same, and it all kind of packs up nicely into one box. This is one of the pieces from that superstructure. What winds up happening is this acts as a stop. So it slides in, that stops, and then back here these plates act as a stop to the insides. So the pieces come in, slide them back, hits this, and then the length is controlled. And then when it's removed, you're left with two pieces that you can kind of see come in here and weld the insides. Same thing on this side, jig was made up, and the purpose of this was to get a 4-degree angle on the side. And when that's removed, these pieces are able to stay in place. The rear arm for ceramic sculpture that is currently in process of being built. One of the main tasks that I'm kind of taking over is some of the driveline components, and really getting into not only the drive systems but also the fabrication behind it. So both fabrication and design. The idea behind this is we're going to be using a center support. It's going to be offset slightly back so that it trails while we drive with it. It's a rear steering system, and it's all the motor support. The tires are very large. You'll get to see that in a little bit. This is the rear arm that's currently in the process of being fabricated. We're using C-channel for the main structure. John's working on the rim. This is how we're going to bolt the hub to the actual structure. We're using, selected a hub from a Chevy van. It's a 3500. It's the heaviest duty thing that we could find. And we're going to use the matching rim. That gets mounted on top of the arm, and then the hub gets mounted directly to the vehicle. And this is the main pivot for our rear steering system. So what we have here is the back plate to that hub. This is something I was working on last night. Wound up boring out the center and cutting the edge on the lathe, and then going around and drilling out the holes on the mill, locating them and boring them out so this will fit. This again will get mounted up to the frame, and that's our main connecting piece. Everything on this will be able to be unbolted, packed down, and serviceable. So this is the superstructure for the kinetic vehicle that we're working on. Again, the main steering components are going to get mounted in the center here. We still haven't built the frame on it yet. The machine piece that you cut on the lathe, that's going to get mounted in the center. That hub will mount into it, and then off of that structure will be that rim, and then come down into the rear arm, which the rear arm will get mounted to these wheels through an axle system, either end having a hub. So that was the back system, the steering system. The front kind of had some unique challenges too. We have 6 people that are going to be pedaling this vehicle when it's finished, and they had to come up with a way to get that energy to the ground and actually make this move. So what I wound up doing was selecting a axle from a vehicle that pre-existed. It had brakes on it. It had these joints here. These are CVs, constant velocity shafts. And that's going to take the energy that's created through the bicycle system, the chain drive that it's not built yet, but it's in the works. It's going to take that energy, transfer it down, and then that's going to come through this wheel, and then through this hub, through the wheel, and then to the ground. Hey guys, I really hope that you consider me. I hope that you enjoyed some of the projects. I got to get back to work. This stuff doesn't build itself.